Hi, very warm welcome to AIMS University, Malaysia. This is Dr. Sridevi. Today I am going to give you information regarding optical isomerism. Optical isomerism. In this session, you'll gain the knowledge regarding what is optical isomerism, what are chiral centers, which compounds exhibit optical isomerism, how will you measure optical rotation, what is the importance of optical isomerism. Optical isomerism is present in all the compounds that contain at least one asymmetric carbon atom. That means at least one chiral carbon. It is another form of stereoisomerism which occurs when compounds have non-superimposable mirror images. The two different forms are known as optical isomers or enantiomers. They occur when molecules have a chiral center. A chiral center contains an asymmetric carbon atom. The asymmetric carbon atom has four different atoms or four different groups arranged tetrahedrally around it. Chiral centers. Here you can see an example of chiral center. A carbon atom that is attached with four different groups or four different atoms is called as a chiral carbon. In the picture you can see a black color ball which is denoting the carbon atom is attached with four different colors around the carbon atoms which are arranged tetrahedrally. On the right hand side you can see a structure which is having a red color carbon showing that that carbon is chiral. It is attached with four different groups like amine, methyl, hydrogen and carboxylic acid groups. So you can say that carbon as a chiral carbon. For a compound or a molecule to exhibit optical isomerism, it should satisfy two rules. They must be mirror images and they must be non-superimposable mirror images. Optical isomers can be distinguished by the way they react with the plane polarized light. The one enantiomer will rotate the plane polarized light towards the right side and the other one will rotate towards the left side. If it rotates the light towards the right side, it is called as dextrorotatory. If it rotates the light towards the left side, it is called as levorotatory. Let me explain you what are non-superimposable mirror images. You can see a structure on the left hand side. It has got its mirror image. Now try to rotate the mirror images and you cannot stake one molecule on the top of the other. That means they are not superimposable, or these type of images are called as non-superimposable mirror images. Optical rotation. Some compounds rotate the plane polarized light and exhibit the optical rotation. You can see the figure here showing the principle behind the optical rotation. Light source produces light vibrating in all the directions. Polarizing filter only allows through light vibrating in one direction. Plane polarized light passes through the sample. If the substance is optically active, it rotates the plane polarized light. Analyzing filter is turned so that light reaches a maximum. Direction of rotation is measured coming towards the observer. If the light appears to have turned towards right side, it is dextrorotatory. And if the light turned towards the left side, it is levorotatory. Dextrorotatory is denoted by D and levorotatory by L. Dextrorotatory is also denoted as plus form and levo as minus form. Coming to the importance of optical rotation. Do you remember the thalidomide tragedy? The drug thalidomide is a chiral molecule and it can exhibit or it can exist in two enantiomeric forms. In 1960, it was used to treat anxiety and morning sickness in pregnant women. Tragically, many gave birth to children with deformities and also missing limbs. You can see two structures in this presentation. It turned out that only one of the enantiomeric form was effective and safe. Its optically active counterpart was not. During manufacture, a mixture of isomers was produced accidentally, and the drug was banned worldwide, but not after tens of thousands of babies had been affected. The structure on the right hand side is safer and the left hand side is the reason for this thalidomide tragedy. Optical activity is common in biochemistry and pharmaceuticals. Most amino acids exhibit optical activity. Many drugs must be made of one optical isomers to be effective. And the advantages of these are they needed in smaller doses, they get reduced side effects and improved pharmacological activity. Thank you for patient listening regarding optical isomerism.